All right. Hey, Hacksters. So yesterday I got a request on a video. Someone mentioned that they noticed we do a lot of interviews, and that's definitely true, but we also do tons of other videos. I asked them what they'd like to see more of, and they mentioned, among other things, how-to videos surrounding Arduino and Raspberry Pi, and also updates on projects that we're working on, and things about tech events and conferences. Well, I have something that kind of blends many of those things together. We're gearing up for Maker Faire and also for the Teardown conference in Portland this weekend, which is being put on by Crowd Supply. Um, as such, the office is a huge mess, and I don't have a lot that's super finished right now, but I can tell you what I'm working on, and it involves a lot of 3D CAD stuff. So, I'm working on adapting the Google AIY Vision Kit to make it more fun, and we're going to put one in the Google booth at Maker Faire. Um, and I thought I'd share some of those designs that I have, like what the design process looks like for that, as well as how you actually go about building something like this, because I've done some trades recently with friends where I would do sort of 3D modeling for their projects, and they would help me learn how to do PCBs, which is great. It helps us both get our stuff built faster, and I think it's useful to just see someone else's process sort of from beginning to end, or at least from beginning to the first prototype. So, I started out thinking of various ways that I could incorporate this robot, this AIY Vision Kit, which detects your emotions and will ideally, open a box so that you can take out a treat or whatever. I was applying some things that I've observed about what makes a robot cute. And those include things like wide-spaced eyes, sort of a bulbous exterior. If you can make it look like a character, that's obviously very cute. You also have two kind of main aesthetics, in my view, of cute robots. There's the sort of marshmallow kind, which I call this sort of bulbous one. And then you have the sort of wall-y kind, which is sort of like non-threatening, kind of cute, small, and just looks like it's having a good time. And maybe a little bit more junky. But that would be in the case I left the AIY kit as is, which you can see in some of our other videos, where it's got this camera lens here, it's got a piezo speaker down here, and it's got a privacy LED over here you can't see in this design, and a button on the top. So one way to create an enclosure for your device, if it already has an enclosure, you can sort of integrate that into your next design. I also thought about integrating like a video screen, for example. And here's some of the PCB stuff I was working on. I'm really excited to share that with you soon. Let's see what else. This is part of the exchange that I did. It's very vague, so you can't actually tell what's going on here, which is good. This is my friend's requested design. It basically uses it's a simple box to enclose some electronics, but they wanted to have a way to plug stuff in, which they weren't totally done prototyping yet, so we left one side with a big gap in it. And then above that gap is a sliding door that sort of closes off one side of it. And this is something that I think is really useful as a design for enclosing electronics, because you can do clips and stuff when you're 3D modeling, but it can be a little bit tougher to get precisely. I found that a sliding mechanism gives you a little bit of forgiveness. But what's nice about this is that you can fit it pretty well. What I do is I add 0.5 millimeters, half a millimeter, on each of space between each pair of surfaces that are going to be contacting each other. And that allows it to have a bit of a friction fit, but it'll fit in, and it won't be super loose and wobbly. So I like to sort of add that into a sliding design. And then all you have to do is sort of add this little lip. You can have the wall as is, like pretend that comes like this. And then you just have a groove going all the way around. And typically what I'll do for that is I just create a sketch on this side, on this face, create a little rectangle, and then extrude it back. If you're not familiar with 3D CAD modeling, that's okay. I hope that this is useful to you in future. Maybe tuck it in your back pocket for for future use. And I always start out by just modeling the size and shape of what I'm going to be enclosing. This is another one that I did. We had some cylindrical objects, and I I just dimensioned everything. Typically, what you would ideally want to use for this is calipers, like a pair of digital calipers, which is that thing that you see with the sort of sliding jaws that open and close, and it'll give you a digital readout. And they have one side of them is designed to fit inside of a space and expand to measure the inside diameter of that space, or just the inside dimension. And then the other side has a pair of claws that are flat in the center, and then they open and close to measure the outside dimensions of a space. And so typically I'll take those measurements, and then I'll see if there are any other constraints. For example, if you're trying to match it to another product, we want to know what the outer dimensions want to be like. And then you just kind of fit those together. For the cylindrical objects in this case, we wanted to have I typically give a millimeter of clearance on each side, because it's much easier to add padding inside of an enclosure than it is to take away material, which you would end up doing by filing or sanding, which is a huge pain, and you never, no, don't do it. You can also add, if you want, you can add a cylindrical hole for putting bolts through, but typically I like to leave freedom for connectors, so sliding lids are sort of the way that I go, because then you print it and it's all in one piece, right? Fitting things together. Oh yeah, and then of course, basically you do a bunch of addition, which is basically like, okay, what are the dimensions of the thing that you're building around? Give it a millimeter of wiggle room on each side. Then give the thickness of your outer wall. So for that, I would typically do 1.5 millimeters for something small, or 2 millimeters for something big or where there's a large stretch, and that'll give you something really sturdy. Like, you can get away with less, but those are like, that's pretty dependable, and it's not that big of a difference. Like, a 0.5 millimeter extra per wall is still just a whole millimeter bigger of your entire enclosure. So unless you're doing something super tiny, those are pretty good dimensions to go with. 1.5 to 2 millimeters. 2 millimeters is pretty hefty, and you will end up with like hollowness in your walls. And none of this is absolute, by the way. This is just my preferences and what's worked for me in the past. Everyone's going to have their own preferences. There are other ways to do it. This is just how I like to. Yeah, so tons of just like, 18 millimeters is the height of the object, the diameter of the cylinder, plus 1.5 times 2, that's our wall width, plus 2 millimeters is the 2 millimeters total of wiggle room, 1 millimeter on either side, and then you get this, your total, which would be what, 23 millimeters, this guy. And then likewise, you have your outer diameter of the thing we were trying to match, or not diameter, outer dimensions of the things we were trying to match, and then the dimensions of, okay, it's obvious it's an 18650 battery. It's just a common size of battery. And so for this battery pack, we've got 18 millimeters across and then 65 millimeters of length of the cylinder, but then plus there were like little tabs soldered to each end, so we had to take those into account as well. And again, it's always easier to overestimate and then, add some padding or whatever. This is just a page of like learning about CAD or PCB design, which is great. And I'll hopefully get better at that and share some stuff with you soon. But yeah, I came up with a ton of different possible designs for this robot. I was like, oh, we could make a little robot that drives around and stuff. This would be really creepy, because it's like, I had this idea that it would look like a person's face and have like the camera in one eyeball and like the piezo sound thing in another eyeball, and then the whole cranium would flip open and you'd have stickers inside. That's a terrible idea. I mean, it's a great idea for like a Halloween party or whatever. Then I started being like, well, what if it's like a cat? What if I just have like something that sits on, a servo pan tilt gimbal? And I came up with this owl design, which I really like. I think it's pretty cute. And also it's pretty flexible, because the more bulbous an owl is, the cuter it is. But it's also got a little face. They've got big eyes that you can set really wide and they look cute. A small mouth is also an aspect of a cute robot, depending. If it's a big like, it can be cute. It can also be terrifying. There's a lot of uncanny valley potential in this whole thing, right? Okay, yeah. So again, I've got like, the dimensions of the servos that I have to enclose as well. Oh no, this is the Raspberry Pi assembly that's got the Raspberry Pi 0W and the AIY Vision fat pea hat. No, it's called a bonnet. Yeah. It's like a small hat for Raspberry Pi, so it's a bonnet. And then the dimensions of the camera. I didn't mind so much about the depth of that, but you always want to make sure all 3 dimensions are accounted for. You've got this LED button and stuff. I was trying to figure out what's the best way to make a cylinder that I'll fit into, but this lip on the top will not go through. And then yeah, just sort of taking into account the entire, this is what my notebook always looks like, just dimensions everywhere. And this is, so like a lot of the work that I do for CAD is, for specifically enclosure design, is just pen on paper. And that's how I get like most of the rough stuff down. And then there's a huge artistic element that I love once you start bringing it into the digital realm. So I pulled this together this morning. It basically starts out with I made a design and then I used the shell feature. I'm just gonna tell you about a few of the different features. I'm not gonna walk you through this from the start, but there are a few different tools that I really like that I don't get to use super much. Uh-oh. And I thought I would share them just in case you haven't seen them before. So had to reload it. Well, while that's loading, Onshape is a browser-based CAD tool. There are plenty of others. I think that Fusion 360 and Onshape are both quite powerful, and also you can use them for free. The thing with Onshape is that you get no private designs. It's kind of like GitHub in that you have, you know, private and public designs, and you pay to have them private. It's taking a little while. But yeah, Fusion 360 is software that has been created by Autodesk that you download, but the designs are shared in the cloud so that you can, if you need to, download the software on another machine and then get access to them, or like you can share them from there as well. What I really like is that they've updated it. They used to require you to go into the online interface just to export your document as an STL file. For printing, which they no longer do. You can do it right from the Fusion 360 interface, and that's great. Both Fusion and Onshape have this way that they keep track of prior steps that you've taken. In Fusion, it's called the history. I'm not sure what they call it in Onshape, but it's just like, so you can go back and modify previous steps like extrusion and sketches and things, and it will automatically update the later steps and tell you if there's a problem. Come on, Onshape, we can do this. Oh, let me try this again. Come on. And what you just saw there was the documents window, which basically shows you all of your designs. And then if you're more of a beginner, you can check out Tinkercad, which is a really simple way to put together shapes. And I should probably show you actually what the difference is. With Tinkercad, there isn't an extrude function. So extrude is, you know, taking a shape and a 2D shape and turning it into like a 3D shape. For example, this cylinder is an extruded circle. I can hide that. Like, if I suppress that, it just goes away. But it is based on this circle that I've drawn here. And so, actually, yeah, what I did was extrude those different circles to different depths to create this little hat thing, and that's where the button's gonna go. This is probably gonna change a lot before Maker Faire, but I'm excited that I have like a design, and then there's gonna be a body piece as well. Tinkercad, instead of using extrusion, you create bodies and you create holes. So you'll create, for example, to make this little hat in Tinkercad, I would create a flat disc, a cylinder, a short wide cylinder for the bottom, the brim, and then for the top part of it, I would create another cylinder, sort of equally tall and wide, and then I would create a third cylinder that is a little bit narrower than that, and turn it into a hole. And then I would stick that hole inside of the other cylinder to get this hollow tube. It's a very different workflow. It kind of makes sense to me. that it would make sense to approach it that way as a beginner. I learned first on Fusion, so I can't really speak to, pardon me, the ease for a beginner. But you know, it's another approach, and having more approaches is always useful. Also, one of the limitations I think of Tinkercad is that you can't enter dimensions, and that becomes a big problem when you're doing enclosures because you want to be you have to want to have really tight, precise control. It helps you align things. So, for example, there's this concept of dimensioning, and let's see, where did I use that? Well, I used that actually in this sketch for the hat. Let's open that up. Come here. Ah, wrong sketch. Come here. Um, Sketch 6, there we go. Oh, I see, it's taking me up to the top for some reason. Okay, and so when I look at this from the top view, I have these 3 arrows pointing to these, and I can move them around, but that's where I can edit how big each of these circles is. So if I want to make it like narrower or wider, that's how I would do it. And then the height of each one is controlled by how much I extrude it. So say for example, I wanted this to be 60 millimeters wide. It would be a little bit wider of a brim. And then when I check that, the entire thing updates, and now my hat is a little bit wider. And then if I wanted to give it a sort of like, you know, Abraham Lincoln stovepipe hat kind of thing, I can either drag this arrow and just do that, or I can edit that directly in here. And Tinkercad only allows you to edit things by dragging. You can't put in very specific values for things, which I think becomes, you know, if you're making something for fun that's like cute and you just want to like, you know, make something that looks cute or cool or whatever, you can totally do that in Tinkercad. Plus, there are a bunch of really cool shapes that they've got that you can just drag into your design that are like bunny ears and like arms and stuff to like make your stuff really pop and be exciting. But once you get into wanting to create more stuff from scratch, then those dimensions and that ability to set how far apart things are from each other really comes in handy. So I want to show you another sketch. Let's see, which one should we do? Um, Where have I got one that's got, oh yeah. So I created these hollows in the eyes of the owl. And I did that by creating large circles that are far away. There may be a better way to do this, but it made a lot of sense to me. And basically, I decided that they should be 40. I created these by creating a half circle and then revolving it around an axis to create a sphere. And I decided that those half circles should be 40 millimeters apart. And that's just an aesthetic thing. So if I make these like 50 or let's say 60 millimeters apart, then when I update that, the owl's face looks completely different and kind of terrifying because they intersect at a different spot because those spheres have been moved outwards. And that's another thing that dimensioning lets you do. You can like easily change the shape of things by just plugging in different values and stuff. Not only that, but you can also create a variable that you use in multiple places in your design so that when you change that one variable in one spot, the whole design gets updated. And that's really useful if you're using, for example, fillets, which is a way of rounding off a corner. If you have a bunch of different ones in different places, then that's really useful for, like, I'll just show you what a fillet is really fast. This is getting a little bit off topic, but it'll be fun. I'll do it on this little brim. No, I'll do it on this big one. Okay. So you hit fillet, and then I've decided that I want a 5 millimeter fillet. That's the default, and it just rounds off that edge, and that can make it can be a big help in making your design look finished, basically. There was one other thing that I wanted to show you though. Oh yeah, lofting! This is the first time I've actually used lofting in a design, and that's because it's really useful for making pyramids, which in the past I used by just like creating a block of stuff and then using planes to chop off pieces of it, and that's the worst approach ever. So lofting is super useful. Basically, where's the loft I've got? Here we go. So to make the beak, for example, I created a sketch first on one plane here. I'm going to show you it's sketch 5, I think. Nope, it's sketch 4. Nope, it's sketch 3. Okay, there we go. So here's sketch 3. It's this diamond shape that I used as the basis for the beak. And there's a point in the center of it, which becomes useful later on. And then I've also created an offset plane. So this sketch, that diamond shape, is on one plane. And there's another plane where I put this point for the tip of the beak. And then I've used the loft tool to basically create a continuous object that goes between those two. So you take this plane, you take this point, and then you just sort of like make them come together. And so you could also do this with just like a smaller diamond on a second plane, and then you get sort of a tapered shape, right? It just takes the one sketch and the other sketch and makes them come together via whatever means necessary. And I really love this tool. I didn't realize that you could use it to make pyramids, but now I'm going to use it all the time because I really like building these things from scratch. So, this is something that's designed more for engineers and stuff. If you want a more organic look in your 3D models, there's plenty of other tools for that. So lots of mechanical engineers like using SolidWorks. Lots of people who are working with more sort of animation and like organic forms like to use Maya, which is another Autodesk one. And then there's tons of other options depending on what you're going for. And then finally, I want to share how do you make this real? So I've got these two parts. I can rename them like the head or whatever. And then I'm going to put a hole in the head that corresponds to where the button goes. But basically, I'm going to right-click on this guy, either here in the parts list or in the design itself, and I'm going to hit export, and that allows me to export it as a millimeter scaled file, STL format. There's other ones as well. You can also create DXFs for milling stuff out. Fine resolution, and I want to download it. For 3D modeling, I usually vastly prefer working in millimeters because it's so much more precise. It's easier to think in for myself. I can use a centimeter ruler, and it's, the markings are so much finer than your typical 1/8 inch or 1/10 of an inch. Oh, because this is a PCB one. Oh. Your typical 1/8 or 16th inch markings on a ruler. I think that's much harder um, to think in. Oh, let's just not do that now. Anyway, so you download the STL file. I don't know why that came up. That was unrelated. But you get your STL file, and then you can send it to Shapeways, for example. Shapeways is a professional printing house that will make whatever you want. It can be kind of expensive, and it can take a while, but you get really beautiful results. And so you can create stuff in all kinds of different materials. If you're making jewelry, for example, you can get it printed in metal for not very expensive. Especially like a small piece, like a ring or whatever, I've done, depending on the material. I typically use brass or silver, and that can be as low as $12 for like a ring, and that's great. It's like your own custom ring, which is fantastic. And then like there's a shop as well, all these shops that people run selling different cool stuff that they've made, including add-ons for electronics and stuff. I really love their work, and it comes out really nice. But then also, if you're looking for something really fast, if you need to make something, for tomorrow, for example, you can use 3D Hubs to find a local manufacturer. So someone in your community who has a 3D printer or 5 or 8, and they run them all the time doing fabrication jobs for people. And it's a great way to support local people and also to get your stuff much faster. So you can choose, after you upload your model, you basically get the options to select what kinds of materials that you want. They also do CNC machining. Oh. So for example, if you want just a basic print, your cheapest option is going to be PLA, polylactic acid, which is available in all kinds of different colors. You can choose the color. You can even drill down and select which particular person you want. That's like an advanced option. But I've been, helping these people get their first CAD models out into the world, and I always recommend 3D Hubs because Like, it's the fastest way, unless you have your own or have a friend who has a 3D printer. This is going to get you really fast turnaround. And people tend to be really, like, the community, the printers are really great. Like, there's a little place for you to talk to each other in the site. Sometimes you can do it over text, but also you can give all this feedback, and they can be like, well, hey, this one part isn't working. What shall we do? Shall I do this? Shall I do that? And they'll help you actually work through the issues. Shapeways also has a couple of utilities for that, so they will do sort of a review of how printable your model is and tell you about any problem areas. They also have some ways of generating your own product, like turning whatever your thing is into a keychain or a ring or a pendant or whatever. And that's kind of cool. So there's all these different tools to help you get started with 3D modeling. And I hope these tips have been helpful, whether you're a total beginner or someone who has been at this for a while. I've been doing this for, since 2014, and I still learn a ton. So yeah, hope this has been helpful. Thanks for watching. Have an awesome rest of your Wednesday.